Earth is once again under the watch of the sun, and this time, the warning lights are real. A powerful stream of charged particles, racing at nearly 700,000 kilometers per hour, is erupting from a rare trans-equatorial coronal. Hole B is a massive breach in the sun's magnetic armor. At the very same moment, far beyond the solar glare, the interstellar comet 3I Atlas has disappeared behind the sun's disk, leaving scientists guessing whether its silence is natural or something more. Many call this a perfect magnetic alignment, a brief cosmic setup, where the sun's open fields connect directly to Earth, allowing solar storms to strike with almost no resistance. Understand why this matters. It helps to know what a coronal hole truly is. Despite its name, it's not a hollow gap in the sun, but rather a region where the solar atmosphere has thinned and magnetic lines have stretched outward into space. These open field lines act like invisible highways, guiding streams of plasma straight toward the planets. Most of the sun's surface traps this plasma in looping arcs, but inside a coronal hole, those loops break open. From orbiting satellites, they appear as vast dark patches, sometimes large enough to span both hemispheres of the sun. When one of these regions crosses the equator, it becomes a trans-equatorial gateway, a channel that connects north and south magnetic systems, sending energy out in a focused stream. That's exactly what happened in late September 2025. NASA's Solar Dynamics Observatory, SDO, captured an unusually wide coronal hole bridging both hemispheres, with magnetograms confirming its field was open and negative, a rare formation outside the quiet phase of the solar cycle. Space weather teams reported solar wind speeds exceeding 700 km/s, enough to buffet Earth's magnetic field directly. Dr. Tomas Iskov, a leading heliophysicist, described such events as the sun's exhaust vents, and where energy escapes unfiltered into the solar system. And this time that vent is pointed right at us. The danger isn't the wind itself, but how it couples with Earth's magnetic shield. When the Interplanetary Magnetic Field, IMF, turns south, opposite to Earth's northward field, the two systems lock together in a process called magnetic reconnection. It's this invisible handshake that lets solar energy flood into the magnetosphere. On the night of October 12th, the effects were immediate. Vibrant auroras lit skies as far south as Michigan and Maine, a sign of direct magnetic coupling. Power grids felt subtle fluctuations, satellites experienced increased drag, and the global magnetic system pulsed like a living organism under stress. This is the stage now set, a magnetic doorway open wide, a stream of solar energy racing toward Earth, and beyond that, an interstellar traveler hidden behind the sun, as scientists prepare for what might emerge next. One question echoes across observatories. Is this coincidence or the start of a cosmic chain? While Earth feels the pressure from the sun's open magnetic floodgates, another mystery unfolds behind that blazing curtain. 3I Atlas, the third confirmed interstellar visitor ever detected by humanity. Unlike ordinary comets born in our solar nursery, 3I Atlas arrived from beyond, carrying chemistry that doesn't match anything familiar. Most comets we know are made of water ice that sublimates near the sun, but 3I Atlas tells a different story. Its tail isn't driven by water vapor but by carbon dioxide, outgassing nearly 8 times faster than water ever could. It's the chemical fingerprint of a traveler forged in the freezing dark beyond. Neptune, a messenger from another star system, bringing a recipe no one on Earth has ever seen before. Astronomers estimate its nucleus to be less than a kilometer across, small, but astonishingly active. Even when it was billions of kilometers away, it was already shedding gas and dust at a rate of 4 kilograms per second. Its rotation period, just over 16 hours, gives it a restless tumble that scatters material unevenly. Instead of the long, elegant tails we see in bright comets, 3I Atlas leaves behind a hazy, lopsided glow made of heavier particles, more grit than glitter. Observations from SDO, Hubble, and ground-based telescopes confirmed its odd behavior. A muted brightness curve, asymmetric coma, and a chemical mix heavy in organics and CO2. As one mission scientist remarked, it's as if the sun is warming a memory from another world. But 3I Atlas isn't just a scientific curiosity. Its timing is what captures attention. In the same week, the trans-equatorial coronal hole sent a high-speed solar wind toward Earth. Seismographs across the Pacific Rim registered a cluster of strong earthquakes, several above magnitude. Earth's online discussions erupted immediately. Could the sun's magnetic storm, the comet's passage, and Earth's tremors somehow be linked? Theories spread fast, suggesting a cosmic chain reaction, a solar trigger, shaking our planet's crust. Yet, when the data is examined carefully, the story calms down. According to NOAA's Space Weather Prediction Center, Earth averages about 15 magnitude 7 or higher quakes each year. Statistically, that week's cluster was dramatic but not abnormal. Mainstream geophysicists find no proven physical mechanism connecting solar activity to tectonic stress release. Studies over decades show that while solar storms can stir our magnetic environment, the forces at play inside Earth's crust are far greater and largely unaffected by solar wind. Still, speculation lingers because timing, even when coincidental, can look like connection. In the scientific world, correlation is not causation, and that's where this story draws its tension. The sun's magnetic breath continues to sweep through space. The comet remains unseen behind the glare, and scientists wait. Some expect 3I Atlas to reappear intact. Others suspect it may fragment or vanish completely. Until that first image returns, every explanation, from coincidence to cosmic choreography, remains open. The sky is quiet, but the anticipation is louder than ever. Now, as October edges toward its final weeks, telescopes around the world are turning back toward the sun's horizon, waiting for the first glimpse of 3I Atlas as it reemerges. From solar conjunction, its fate remains unwritten, but astronomers are watching for 4 possible endings, each leaving a signature carved in data before the comet itself is ever seen. The simplest scenario is survival. If 3I Atlas endures its close pass, it should reappear with a steady brightness curve, exactly as models predict, compact, stable, and unchanged. That's the outcome most scientists expect, though it's also the least dramatic. The second possibility is fragmentation. This is where the story could shift suddenly. Spacecraft like SOHO, Stereo, and Parker Solar probe would capture a sudden burst in brightness, a telltale sign that the comet's nucleus has split apart. Images might reveal a faint trail of fragments, stretching along its orbit like a broken string of pearls. When a comet fractures, its dust cloud expands, its coma softens, and sometimes its tail forks into 2, one pure white, the other tinged yellow by sodium gas. It's a pattern witnessed before in comets like Lovejoy and Ison, where a brief flash preceded complete collapse. Quieter outcome would be dormancy. The comet might survive but lose its drive, emerging dim, its outgassing silenced, its tail barely visible. To ground-based telescopes, it would appear as a faint, star-like point struggling to stand out against the background. In that case, 3I Atlas wouldn't have died, so it would simply be sleeping. But the final, most dramatic fate is total disintegration. In that version, the comet doesn't return at all. No nucleus, no fragments, no trace, only a fading dust arc in the sun's wake, a ghostly reminder of what once was. For the teams watching, every 12 minutes brings a new image from SOHO's LASCO C3 coronagraph. Somewhere in those frames, pixel by pixel, the comet's future will reveal itself. Once a possible signature appears in a flicker, a distortion, a sudden bright point, automated telescopes like Pan-STARRS and Zwicky Transient facility will sweep the region, comparing fresh exposures against star catalogs in real time. Each detection, no matter how faint, adds to the chain of evidence. Amateur astronomers join in too, uploading their own images from small backyard observatories, sometimes confirming discoveries before official data pipelines do. It's a collective effort, a rare partnership between machines, professionals, and passionate skywatchers. And while the world waits for that first confirmation, another light already rises in the east. Comet C2025A6 Lemon glides through the constellation Cancer, visible just before dawn, a quiet reminder that cosmic stories never stop.